Sometimes when we draw Lewis dot structures, if there are many options, there is one structure that is clearly more favorable. But sometimes there can be more than one structure that are equally favorable. Take, for example, the nitrite ion, NO2-. We could have a single bond to the oxygen on the left, which would then have a negative charge, or we could have a single bond to the oxygen on the right, which would then have the negative charge. These two structures are precisely equivalent, so which one of them is correct? The answer is that technically neither of them is correct, or at least neither of them accurately describes the true nature of the molecule. We know that a double bond is shorter than a single bond, but experiments show that the NO bonds in this molecule are identical in every way, as the molecule is symmetrical. That means that the reality for this molecule is somewhere in between these two structures, which we must call resonance structures. If a molecule is participating in resonance, it is able to delocalize electron density and distribute it in a way that cannot be represented by an individual Lewis dot structure. It must combine them to form something in between the two. For example, each resonance structure has one double bond and one single bond. So the reality is that there is partial double bond character, represented by the dashed line, on both sides, almost like 1.5 bonds. Shown here is the resonance hybrid, or the composite resonance structure, which more accurately describes how the electrons are distributed in this molecule. An important thing to note is that it is not the case that the double bond is flipping back and forth rapidly, but rather that electron density has spread out to give a partial negative charge along the entire area of the molecule. Here's another example, the nitrate ion. This one has 3 resonance structures, each of which shows the double bond going to one of the 3 oxygens. If the true structure of the ion involves an averaging of these structures, then there must be some double bond character all around the molecule. Once again, although we can look at resonance structures to give us clues about how a molecule will behave, none of these 3 structures actually exist. The reality is the resonance hybrid, or composite resonance structure, which spreads out the electron density in the double bond so as to be delocalized around the portions of the molecule that are exhibiting resonance. This may sound strange, but there is overwhelming evidence to support this, from studies that show all of these nitrogen-oxygen bonds are identical, giving the molecule symmetry, and also from the way these kinds of molecules react with other molecules. Resonance is a strange concept, but it is real indeed.